Hello to viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about grid scale energy storage, reality versus fantasy. So let's dive deep into it. Now, what exactly is the problem? Basically, right now, as we speak, we have two major energy sources, renewable one, which is solar and wind. Now, here's the deal. I'm old enough, and many of you may be old enough where you remember in the early 2000s and 2010s, like that time frame, everybody used to say, oh, solar and wind will not have the capacity to run a nation. Now, nobody says that. We have crossed that threshold. Like, completely at this point in time, if somebody's like, oh, solar cannot power a nation, and I mean China, India, USA, big puppies, they are just wrong. Like flat out, you might say it has some issues, which again we're gonna discuss, but it's done. Power wise, done. Go home, sweet dreams. So solar only works on the day, wind does work 24 into 7, but they are intermittent, meaning they have their own mood. They can give you GG amount of power, especially in wind. Like wind has really bad habit of going overboard. And I do not mean 100%, I mean more than 100%. Don't ask me how that happens, but it does happen. So wind can go YOLO, like really YOLO. Solar, basically you could be like, okay, let's build it for worst case scenario and like, bad and cloudy, and then you have zero cloud and what the hell? Or opposite could also happen. You want energy, but it's like, nope. So there is a mood there. And his deal. What about the cost, right? Everybody used to talk about like, oh, it's expensive, expensive. Not anymore. Let that be very clear. Not anymore. This is why I'm so frustrated at people who are like, oh, nuclear, nuclear. No, you can't do that. We have been trying it from 1950s. It does not work. Why? It's expensive. Meaning at this point in time, whenever you are talking about energy, you're not talking about just energy itself. Like, okay, I have coal power plant. This is the power cost. No. What is the alternative that people have? Meaning back in the old days, you only had coal power plant. You did not have too much. Hydro, again, it was very region selective. So you would not build coal power plant where you could have hydro power plant. So that's how it balanced out. Nuclear, you did have flexibility, so people jumped into it, 1950s. But over time, especially after 2010, coal and solar started to compete. Right now, as in 2025, solar is more expensive than coal, flat out. Like it's not like, oh, little bit, no, flat out. Flat out, meaning the only reason coal power plants are working is because of what we call a government power purchase agreement, which are generally signed in years and sometimes are decades long or half century long. Although I don't think any government honors it if it's once like half century long, as in like 50 years. I think 25 years is the valid term, but you get the point. So solar price went down too drastically. At this point in time, you just cannot compete with solar simply because nothing is cheap enough. And you're like, oh, it's not 24 into 7. Does not matter, it's cheap. Like if you have cheap energy, it negates anything else. Meaning if a government has to take out a loan, right, they will have to take out a loan to build a solar farm, and let's just say they have X amount of money, they can build Y amount of capacity. And if you want to do that with nuclear, by the time nuclear plant would be built, solar would be like, bro, we are already doing ROI. You can't build a nuclear plant as fast as a solar system, and not alone coal, and nuclear is more expensive than that. So it's like, it's not happening. And here's the, you're like, okay, but it's gonna work for a very long time. No. If your investment time, like basically I to give you the money, you start building it, when it starts to generate profit, if that gap is long, let's just say in solar it could be as small as 2 years, and I'm talking giga farms, as in like gigawatt hour capacity. 2 years, very low interest rate loan. 10 years, ludicrously long interest rate. And again, it's not 1950s where it's like it's a guaranteed. Why? Because solar is already here, which is already cheaper. Meaning if any company figures out how to make a multi-junction solar array, which again more than enough people are working, which will be 30% efficient compared to 20 which we have right now, yeah, that's not going to be very comfortable. And be mindful, solar panels do pay off their price. And if it's not doing that, especially if you're in America, you're like, no, it's so expensive. Yeah, you have bureaucracy problem, not the technology problem. You have bureaucracy problem. Like 10,000 rules and regulations, that's the problem, not the panel. So that has happened. And again, why coal is expensive? Because again, coal, early days, you start to mine on the surface level. Very easy, cheap, take it and go. As you start to deplete that, you start to go downer, deeper, deeper, deeper. And here's the, now you're burning more diesel just to go there. You're using more boom powder just to reach there. Penalty, price per ton of coal goes up. And that is worldwide. Same happened with gas also. It's like gas, early days, gas. Now it's like, okay, we have to do fracking to get gas out. Like, yeah, it's expensive. So fundamentally, we have crossed the threshold, so to say, where coal is not cost effective enough. Solar is the most cost effective, wind second by, and everything else is afterwards. However, these are all assuming without battery. And again, that's why we are talking about the system. So meaning it's much easier to get out a loan for getting a solar. Again, I'm talking from a government's point of view, and they can just do it. Like, and again, as years will progress, We know the technology like multi-junction solar cell does exist. There are certain multi-junction solar cell that exceeds 50% efficiency. Science is done. It has been used for military satellites. It's done. We good. We got this. It's just expensive. Somebody will crack it how to make it cheap enough. Ta-da! So fundamentally, now fuel cost makes it fixed. As in, at this point in time, wind and solar is going to be the backbone, and hydro maybe, because again it's very location dependent, and on top of that, it's not doing very good because again most of the planet is drying up. It's not doing very good, and again, if you are close to equator, you have a reservoir, you kaput. Need proof? Look into all anyone, be it Iran, be it India, be it China, be it even USA's Three Gorges, Hoover Dam. Looking at it, it's like I think 25% of what 25% below where it used to be, and that's year over year. It's not like okay 1 year drought. No. It's continuous. So fundamentally, that was also not doing very well. So all this makes a scenario where only renewable makes economic sense. That's the best part. Second, we have our own mood. That's the biggest issue. That's why we have not already switched to it. We want 24/7 power. That's half of the equation. We want on-demand power, meaning how the heck our grid works. Now, this is a very critical aspect. It relies solely on inertia, as in if a smelter, let's say a 10 megawatt smelter was turned on, boom, why didn't our grid went kaput? Why didn't all the fuses blew up? Well, it leached energy, right? The system that is draining energy leached energy from transformer leached it from high side transformer. It keep going back. Where's the end point? A generator. Generator strike, basically stator will be the part which will dip. Rotor, it will start to leach energy magnetically from the rotor. Rotor will start to slow down. But here's the deal. Rotor is heavy puppy, as in 100 ton or hundreds of ton. So it is so heavy that it will take time to slow down. Law of physics, inertia is so powerful. It will take time. It's like, yo, it took time to spin up. It will take time to spin down. You leach up. But here's the deal. There is a monitor, or which we call governator. So that monitor will be like, 60 hertz. Okay, cool. Why the heck it's going 49, 59, something like this is exaggerated. We do not go that low, but you get the point. And it will detect it because again, time domain has been instead of one pulse that fries every short circuit, we have like slow. That is slow enough where steam valve will be like, whoa, let's open it up. And again, you will have generally a bit of surplus steam pressure until you can increase the coal flow. So because you can increase the reaction time, all the systems become stable. That's how our grid works. Without inertia, there is no grid. Like flat out, you cannot have a grid on inverters alone because this system works. Known, time tested. That's how all generators are synced, and we have massive spinning mass right now. Collectively speaking, all power plants are synced to each other national wise. So they are massive amount of inertia. That's how we survive everything. And not to mention, they are very important for short circuit, meaning if you have a short circuit, there is a surge of power. Where the heck that power came from? Short circuit creates what we call infinite load, or not infinite, as in like as long as it can create it, it creates that. Where is that oomph is coming from? It's coming from this. That's how circuit breaker trips. If you do not have that, which again many solar farm is learning now, is that that cascade failure could be triggered because again the circuit breaker that's supposed to trip, they did not trip. A silicon diode cannot match this puppy's oomph. So that creates an issue. So we need inertia. Inertia is not something we can work. The most optimistic people I'm in touch with, even they are like, no, we do need some. Like again, you can reduce it. We can have a scenario where it's like, okay, instead of 100% being spin mass, 50% is only spin mass. That is doable. But if you start to reduce it to 10%, then it's like, that's and again, people are not that serious because they are thinking ideally that hydro should have enough spin mass forever that we can handle it. But again, that's way too optimistic. So reality is we all have our own mood basically when we want power. Now inertia gives us that buffer reaction time. That means we should have something that is on tap. Basically, whoa, open the tap, let the power flow. And if this mismatch is not managed, this will not work. That's the main issue, mismatch. We have crossed the threshold of cost. We have crossed the threshold of basically ability to power the system. That is done. But we do not have energy storage tank, a buffer that is big enough. Like again, if you had talked about in 2000s, it's like California will be so solar powered that we have to shut off all power plants, like divert electricity or do something. They will laugh you out of the room. Here's the duck curve. Now people are saying we should not call it duck curve because that was established in 2015, 2016. We should call it California crater. Simply because by 2023 it started to go zero, as in none. Turn off system. Basically, just disconnect. That's how much solar was being generated. So we have to have a scenario where we can balance those out. Otherwise, we are kaput. So this is a fundamental problem. Cost is sorted, amount of energy is sorted. It's just that we need inertia and we need enough of it on tap to make everything stable. So the most time-tested tool, I've already talked in this detail about it, so I'm going to give you a cursory glance of it. Pumped storage. Now, this puppy started long ago, as in like Switzerland and Italy started to work with this puppy in 1900s. And actually, you can go even further than that if you're like, grain mills used to have their own storage. So it's like, okay, this season we really need to like, continuously run the grain. So it's like, okay, let's have a dam and then just like open the dam in the, harvest season so you can keep crushing. So 1900s, like very early on. And by the time Industrial Revolution became electrolyzed, as in like 1910s and 1920s, by 1930s, many nations, Japan included, all other nations started to build pumped hydro, big ones, kilowatt to megawatt ones, to actually like, have handling capacity. And then something bad happened, which we call a nuclear fever. So nuclear boom happened, and by 60s we started to make these puppy large. Now like, okay, why did nuclear create that? Well, nuclear had a problem, is that unless you can run a nuclear power plant to fixed load, the ROI is not guaranteed, so to say. Again, so everybody's like, okay, instead of making super large oversized plants, we make decently sized one with a little bit of overroom, and then at night when the load is low, we're gonna charge these pumped hydro batteries, and during day peak time or specifically evening peak time, we're gonna dump it. So that's how we started to go into gigawatt hour scale. That started to happen in 60s. And how long these batteries work? Well, as long as you maintain it, meaning these do not have fundamental lifespan limit. Of course, they have wear and tear, but they do not have fundamental lifespan limitation, meaning they can keep working. And the best part is when they are discharging, they have physical inertia, meaning even if you are like, let's say for some reason, let's say wind gave you a lot of power in night and you're like, okay, let's discharge it during the day, and like somebody turns on smelter, this puppy is like, I got this. This is the rotor puppy. Big puppy is like, I got this. So fundamentally inertia is there, so meaning everything about your circuits work, everything about the grid is stable, and it also has good round trip efficiency. And this is the interesting part. Many of the plant, when they started, they were at 72%. Now we are touching 80%. Some designs are almost claiming that they could touch 85%. So it's actually getting better. Now, how much water we are talking about? Well, to get 1 gigawatt hour roughly, you need 1 gigaliter. So it's quite big. It does require big. So that's the penalty. It does require you to spend some time and money to build it, but it does scale up. Like how big? Well, China has one stupid one, which is Fingyun Pumped Storage Power Station. That puppy power rating is 3.6 gigawatt. Now here's the deal. Whenever you're talking about like this sort of big numbers, they are not one generator, multiple of them. 3.6, that's huge. And what about capacity? Yeah, that puppy goes up to 40 gigawatt hour. The reservoir can be seen from satellites. It's huge. So fundamentally bonkers amount of, meaning this puppy can run a metropolitan. Is like, bro, we got this. I got this, bro. I got this. And if you have wind, it was like low power, like again, wind generally does not go off. It goes low power. This is like, bro, we good, bro. We good. We got this. And you're like, okay, that's a new one because that was finished in 2024. Well, if you want to go old, like old big one, the oldest big one I have seen is Bath County Pumped Storage, that is in USA. That is in 1977. Again, gigawatt scale. I think 20 gigawatt hour, and big ones, like big puppy. And it's been working. It's been working. They had like normal survey, like exactly the same thing you do with the hydro plant. Normal things, go home. And the best part is no advanced technology required, meaning you do not have to worry about sanction, technology, nothing. You can build it with technology of 1970. It was built with 1970s technology. Most countries can do that. You do not have to worry about it. It's simple. And it does not require synthetic grid forming, meaning you are not like, okay, what if we have a magical inverter that can create similar properties as this? It's like, yeah, what if you don't? What if instead of spending millions of dollars, what if you spend $1 million to just get this? I'm simplifying, but you get the point. So it has no life limiting part. That's the best part. And nowadays we have advancement. This is India's currently being built, as in like 1 gigawatt is active. We are scaling up to 2 gigawatt. So this is variable speed rotor. Now like, okay, how can you have grid inertia and have variable rotation? Is it VFD? No. Some people did try to switch to full VFD, but that backfired. They're like, you need inertia. So this is what we call doubly fed induction machine, as in the rotor, instead of getting DC current, goes full-fledged 3-phase AC waveform. And that waveform is counter rotated, or like basically the slip is controlled. Why would you want to do that? Well, again, because you're talking about pumped hydro, the water head affects how much you want the rotation to be. Again, this works quite fine enough. Again, that's how every single hydro dam works. It's just that you want to optimize that round trip efficiency. If you want to push above 80 or even like 75%, you do want like a bit of rotation change. Like if it's rotating at 600 rpm, like okay, what if it was 650? What if it was like, you just want to tweak it? So we control the power going into it. Now, how much power? Let's just say this puppy is 250 megawatt rotor. You will control 10 to 30% of the energy will be taken out, went through basically what we call VFD. Basically, you convert AC to DC, then DC to AC, and then you will control the slip. That's how you can change the rotation while still maintaining synchronization. Why? Because the stator did not change. Stator still behaves exactly if it has a rotor rotating inside. It still does. Oh, by the way, this was the old topology that every wind farm had back in the like I would say 2010 to 2015 ish. Most wind turbines were working on that philosophy, but it destroyed the gearbox because again, wind's emotional. You can't be like you have to rotate like water. You can control it like you have a sluice gate. Wind you do not. So this works. And it gives you grid forming. It gives you, and these are also capable of black start, meaning if your grid goes kaput, you can start it. And these are very good. And again, somehow Australian people are becoming smart somehow, and they have the idea that hey, we had this mine, gold mine, which has become useless. Again, there's still gold. It's just too expensive to take it out. It's not profitable. So they're like, okay, what if we use that as the ground sink for basically the down reservoir and have a pond-like structure for upper reservoir? Tada! And they have a solar farm and they have a small wind farm there. Tada! Done. Flat, middle of nowhere. They still have like power. Take it and go. Like it's such a clever use. I'm like, and again, Japan also had like pumped hydro where they're like, okay, they had certain place that was like next to a cliff and there was a sea. So like, okay, why build a down reservoir? Just use sea. Again, you have to deal the corrosive aspect of seawater, but we good. We got this. So there's a lot of option. It works and it is very desirable simply because of real inner. Basically, when you're discharging it, these puppies like, I got this. Meaning you do not have to worry about while discharging. Charging, it's load. While discharging, it is a true generator. So this is pumped storage. Really robust, time-tested. Switzerland ones are claiming 85%. Now we come to another part, which is TES Retrofit. As in, we have a lot of coal power plants. Even China has bonkersly large number. India also has some decent number. We are looking at 2,000 coal power plants worldwide, which is a lot. Now, here's the most of them has to shut down. Why? As solar prices comes down and wind prices come down, they will not be cost effective. They will only survive on what we call fixed power purchasing agreement and those sort of things. So they have to shut down. Like sooner or later, again, that could happen as early as 2030s, as late as 2070s. It will happen. It's a fixed thing. And again, you want to do that simply because why do you want to, give people sulfur poisoning? Why? So fundamentally, dropping price of solar and wind will make that absolute guarantee. So here, why throw them away? Why let them, decapitate? Just convert them into battery. How would you do that? You take the coal section, basically the coal storage, yeet coal storage. The bulk cruncher, you yeet that. The furnace, you yeet that. Then you keep everything else, basically the wiring, the substation, the control mechanism, the SCADA system, basically the whole steam cycle, including cooling tower. You keep all of that, and instead of having coal furnace, you have this, basically a graphite block, this puppy. This is from E2S Power, and this graphite block has the ability to store energy. How? Well, it heats up. How hot? Well, graphite can easily go up to 3000 degrees Celsius. And again, it's surprisingly easy to heat them. Why? Because you can just directly have conductor on the left and right side and directly dump energy into it. Basically use the block itself as a resistive heating. That's the easiest way to get a bonkers amount of temperature. Here they are not trying that high, because while coal furnace does have stupid high temperature, as in like 1600 degrees Celsius, water does not get that high, because again, you have a flame and then you have air, then you have radiation. The conduction efficiency is not that great. So temperature is not that high. Here, the pipes are in the block. The block is hot. So solid conduction. So they do not need very high temperature. So they are only heating it up to 1500 degrees Celsius, or maybe even 2000, depending on their design. You do require inert environment, otherwise it will catch on fire. So you can put nitrogen if it's low temperature. You can put argon if it's stupid temperature. 3000 is stupid temperature. So that way you can basically charge this puppy when there is surplus solar and where there is surplus wind, and discharge it when you have load. and it behaves exactly like a coal furnace. As in, the high pressure water goes in, high pressure and temperature steam comes out. The end. Like, does nothing has to change on your steam side. Nothing. It's not, oh, it's lower temperature. No, that's the benefit of using graphite. It has exact same temperature characteristics that people are used to, that's people designed to. And actually, it can go higher than what coal can do, although it will require argon sealing and all that. So, but it can be done. So you have no longer pollution. There is no fire. There is no pollution, no carbon, no this treatment and that treatment, nothing. Kaput, done. Everything is sealed. It's just heat up during the surplus time and discharge during the demand time. The end. They are very cheap because, again, most of the things are there. And this thing is dumb, as in it's a graphite block with the pipes. The end. Nothing complex. And it has a real inertia because, again, that's how we had inertia. So everything is there. But it does have poor round trip efficiency. So round trip efficiency here, it drops to 30%. Again, electricity to heat, 100%. Heat to electricity is only 30%. So you should ideally want to utilize that waste heat into something. I'll talk about that, but you should do something there. But even because of the low cost and the fact that it has inertia and the fact that we have already built it, it can easily give a very good second life. And you're like, okay, is it economically viable? Yes. During surplus time, power prices goes down so much that you can afford to waste it. It can be done. And again, you do not want your grid to shut off. You do not want duck curve to become, California Valley. So how does all this thing compare to battery? Because everybody's like, battery, Elon Musk, battery. Yeah, battery is what we call Faraday's solution, as in it does a redox reaction. Now, it is great for DC system. I think this is the puppy. High round trip efficiency, we are talking at 90+%. As in, if you're getting below 90%, something is wrong. Like, this is good. Epic for small scale, as in electric vehicle, 100 unit batteries, house, 200 unit battery, off grid, you can go YOLO on it, but it does not scale. The moment you want, like, okay, I want 10 gigawatt hour, which again, 1977 we had 10 gigawatt hour. So if you place the order for 10 gigawatt hour, you'll find very quickly it's not that easy. Like, the moment you want to scale it up, it's like, yeah, it does not scale. Like, people are trying their best, it just does not. And be mindful, it's DC. So that's a very serious issue. Because again, there is no inertia. So once you have something like this scale and any minor issue happens, and if the substation cannot kaput it, bad things happen. So that's there. And fundamental degradation of energy carrying capacity, that will happen no matter what chemistry you have. Again, it could be delayed. It cannot be stopped. It's like a death. So you have a cell, 100, let's say it's 100 gigawatt hour. Let's say you went YOLO on it. It will become like, a 20 gigawatt hour over time. It's not like pumped hydro. We started with 70% efficient and now it's even better. It will not do that. So that's a serious issue, meaning not only you have a capital expenditure, you have a running cost and you have an inferior system. Inverters cannot give you same characteristics of a physical mass inertia. Why? Physical mass inertia is infinite resolution. Like, you can take a best A to D, it still has a limitation. Compare that to a spinning mass, sine wave is completely smooth. Infinite. Okay, keep slicing it, it's still smooth. So again, that's the benefit of analog systems. So there is that serious issue, meaning you can fall into, hey, we can build it quickly, like how solar you can build quickly. Same, this does have that. Like, hey, I start on this, it can be done in like 2-3 years. As long as you can transport it, done, go home. That's the good part. But it does have high OPEX. Even though it does not have people, it does have, those things are being consumed. You have to keep replacing them. And even losing few percent on grid scale, that affects a lot. And like, didn't Australia did that for grid stabilization? No, what they did is, like, they were reaching the peak capacity of their power plants. Power plants are like, bro, we do not have enough energy. At that point, battery is like, I got this. Basically, battery was shaving off the peaks, not stabilizing the grid. It was just like, whoa, overloading, I will take care of it. Surge off the power. That is really good on that. Like, battery is really good on that. But other than that, it's like, not there. So this is the battery aspect. Like, this is law of physics. You can delay it, you cannot eliminate it. It does not matter. Instead of using lithium iron phosphate, I'm going to use lithium titanium oxide. Does not matter. And especially at this sort of scale, especially if you want to do regular deep discharge, yeah, good luck. Again, it's gonna last 10 years, 20 years, 30 years. But once you have enough loss of capacity, it will start to affect your bottom line badly. So what's the reality of it? Well, reality is very simple. A right tool for the right job is necessary. Meaning, if you are doing something off-grid, go YOLO on battery. Of course, I will also do that. That's logical. but you can't waste money on magical grid forming inverters. I've looked into the pricings of these companies who are like General Electric and ABB, Siemens. These companies are like, we are working on grid forming inverters. Yeah, that's stupid. And not to mention, there are only few companies that are even claiming that they can do that. So that creates a very serious issue, meaning they will have service contract for decades. And it's a black box, meaning nobody else should touch it. Like generator, you can certify anybody from school to work on generators, as school, not like college, professor, and all that. It can be done. You have training programs, apprenticeship, good, got this. You have enough generators, go YOLO on it. But when you're talking about grid forming system, it's like, ooh, how does it work? Who knows? And national infrastructure should not be something that is controlled by few. I do not like this idea. I do not like the idea that somebody sitting somewhere else can decide what happens to Indian grid. We already got bitch slapped by GPS. It was good bitch slap. It treated us that thou shall never have weapon system from someone else. We started to build our own navic system, our own navigation system. Same should be here. Thou shall never rely on grid forming inverters, because again, that's someone else controls. So that's not, again, you can buy generator, you can buy a stator and all that. Who cares? Because again, once it's in your hand, it is in your hand. There is no software updates on that. So fundamentally, it's, and again, it should not be fragile, like, because once you see how complex, and again, this is a dumb one. There are certain inverters that are used in HVDC, again, to convert a high voltage AC to high voltage DC. Those have 200 levels. I did not even know there was something known as multi-level inverters, and they have like freaking 12 levels. And again, you have to do that so you can have like good harmonics. I'm like, what the hell? What the hell? It's the same point. It's like, can you use a flamethrower to light a cigarette? Of course. Should you do it? That's the whole point. Should you do it? No. Again, you do not want something like, oh, somebody. These are the algorithms, my man. Like, it's not that it can't be done. It's just that why? Why use a flamethrower? We got this. We solved this. Like, we do not need to deal with this power calculation, primary controllers and secondary controller, voltage controller, current controller, inverter systems, PWM generator, PCC follower, virtual impedance, yeah, we do not need to deal with this. Like, we good. We don't need to deal with this. That's the whole thing. It's like, I do not like this idea of, again, for a nation point of view, it is way too finicky. And again, what about test systems? While test systems is really good, cheap, and effective, it does have waste heat. But again, you can do something useful with waste heat. For example, in India's case, those coal power plants that are next to the sea, we can utilize low temperature thermal desalination. Basically, instead of getting waste heat, we get distilled water. Good, awesome. Second, if it's a landlocked and if it's next to a major town, district cooling. Tada. Or district heating. Like, how the heck you're going to get cooling from waste heat? You run what we call absorption chiller. Ironically, coal power plants already have that. To do the auxiliary cooling, that's how they do it. So it is doable. It's a normal thing. It can be done. So, and again, this means you can actually start manufacturing them rather than like, okay, we have the old structures. Those are cool. Like, you use them, reduce carbon footprint. That's the best thing. But once you're like, okay, those are reaching the final level, you can retire them. You can like, okay, let's design something that is specifically for energy storage. You can put it like in a city center. So you get maximum efficiency. There are a lot of things that come up, but I do not like this idea for a grid level thing. Like, yes, you can do this, but why? Why not trust mass that is dumb, that works, that does not care about earthquake, does not care about EMP, that just works and robust, rather than like 200 levels. That fried my brain. And oh, by the way, they have to make sure all switches are worn out similarly. Like, that's the thing. The switches wear out and they have to wear out similarly. So they have to change the algorithm in such a way that, okay, now this has been worn this many times, this has to be done. Like, they are balancing the PWM on time. I'm like, why? Again, I love this technology. This is awesome. That's how you have your electric vehicle going YOLO in terms of speed, but not for national grid. Right tool for the right job. So this was my presentation on basically energy storage for grid scale. Hopefully you have liked it, learned from it. In that case, please click the like button, share it with a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show my excitement. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon for free, and as always, thanks for watching.